So today we'll be doing this question called promise pool. So so basically in this function, like what the question says is, given an array of asynchronous functions and a pool limit n, return an asynchronous function promise pool. It should return a promise that resolves when all the input function resolves. Okay. Now let's see what pool limit is. Pool limit is defined as the maximum number of promises that can be pending at once. It is defined as the maximum number of promises that can be pending at once. Also, promise pool should begin execution as of many functions as possible and continue executing new functions when all old promise resolves. So it says that should begin execution as many functions as possible and continue executing new functions when old promise resolve. Okay. Promise pool should execute function I, then function I plus 1, then function I plus 2, and etc. Let's say for an example, if n is equal to 1, promise pool. Promise pool is what? It is the limit that it is the limit, right? That we give to our function, like how many subsequent threads or pools we can run, है. So this is what it is, and the other thing is we'll execute on how okay, for example, if n is equals to 1, we'll execute one function at a time in series. However, if n is equal to 2, the first executes two functions. When either of two functions is resolved, a third function should be executed. Okay. And so until there are no functions left to execute. You can assume all functions never reject. It is acceptable for promise pool to return a promise that resolves to any value. You can assume functions never reject. So we have these things, function never reject. It means every promise will be fulfilled. Okay. It is acceptable for promise pool to return a promise that only resolves any value. Okay, fine. So let's see this diagram. So it is saying that, just a second. Okay, it is saying that you are given an async task A, B, C, D, E, and a limit equals to 2. Okay, now run at most limit equals to 2 means we need to run at most 2 tasks. Yeah. So okay, so we need to run at most 2 tasks. When a task finishes, start the next one and return the result in the original order. So the main thing over here is order should be preserved. Order of execution should be preserved. Okay. So this is one thing. Now let's see what is happening over here. So sorry. So task queue. Okay, so this is the queue, right? A, B, C, D, A, and E. So in step 1 we have 2 tasks. Okay, see this. Here we have 2 tasks, A and B, running maximum 2, right? Like only 2 workers can start at once, right? Now, okay, in step 2 B finishes, then the second task which starts is C, and C is currently in waiting queue, so C goes here. Okay, nice. Now C is complete. Now A is completed because the delay or whatever for this task has been completed, so it has resolved. So now we have one empty over here. So C is already there, so the other thread will start working on D, right? So simultaneously our C and D both are currently working. Now C also completed, so now we have D and E, and at the end everything is resolved and we will return the result. So basically there is nothing, it's very simple. To understand, it is like, let's say we have two threads. Sorry. We have two threads of sorry. We have two threads A and A and B, right? A and B. So like we have two threads A and B. Each thread, because our limit is 2, and where we have five tasks. Let's say we have tasks 1, 2, 3, 4, 5, right? We have 5 tasks. Now initially task 1 will start. So this thread will have 1, and this will have 2, right? Now let's say the delay for this is 1000, and delay for this one is 2000. So this will resolve, right? This will resolve. So resolve, so B is empty now. B is empty now, so our third task will come, our task 3 will come. So task 3 will come with delay, let's say again 2000, till the time this task 3 is getting executed. Our 1 would have been completed because 1000 this, so our task 1 will also get resolved. This is resolved. Now A has an empty slot, so task 4 will start. 4 is also having delay 1000, so it will start, and by this time 4 is 1000, 3 is 2000, so 4 would have already, 4 and 3 both will resolve nearly, like how much is 2, 1, 2. Okay, so these will resolve at same time mostly. So let's say 4th is also get resolved now. Okay. 4th is also resolved, and this also gets resolved. Now we have only one task left, so it will, let's say, come here, and 5 has some delay. We have some, it will be having, let's say, delay of 1000. So once this is also done, this will also get resolved. this is also resolved. Now this everything is resolved, so our whole tree will get resolved, and it will give us the output, and the output would be all the tasks in the given order, whatever it is, right? 1, 2, 3, 4, 5. So this will be the output. Like, this is the basic idea of how this thing would work. Now let's see the code, so that you will understand it pretty easily. So okay, so how we are spinning the task over here is we are creating this where it is, yeah, so we are creating this delay function. Delay function is nothing, it is a simple set timeout which has like given, like, we will give some random delay to it, and we will resolve it with some xyz values, right? So over here we are giving a b c d. So millisecond is the delay we will give, value is the value with the promise or will resolve, and we have this task array which will take all these delays, and we have created it, right? Our maximum limit over here is 2, and now we will give this to this run task function, which will act as our pool, right? Now what this run task function does, it will create pools, right? This is pretty much clear, I guess, right? Now how we are creating the pool over is, this is what you have to see. Okay, so currently let's say we have tasks and limit. We will have an initial index and an output where we will be storing everything, right? Now we will create a helper function, or you can say a runner function, or whatever thread, whatever name you want to give. Now how this will run? So our helper function will run till the like, we will start a while loop starting from the ith index, like that is the starting index, till the total task array items are there, right? Total tasks are there, and every time we will increment the index. You can increment over here also, post trying, but I have post incremented, so our next try would always have this. Now as our order has to be preserved, so the output would for that particular index should be stored in that particular index in our output array also. Like, for output of the first item in the task array should be installed, should be there in the first first place at the output array, right? Now what we are doing here is, so our task is nothing, it is a array of promise. So every ith index will have a promise inside it, so we are just consuming that promise. So the way to consume a promise is, we have an asynchronous function, and we will await the promise, and we will consume it. Okay, whenever we get the data, we will update it to this output. If we get an error for that particular index, we will add the error to the output array. This is how the simple helper function works. It is pretty much easy to understand, right? Now the main step is spawning our threads, right? So over here we are spawning our thread. So what we are doing is, we are creating an array of length, whatever is the minimum, the limit we have, or the task array length what we have, right? Let's say we have a limit of 2 over here, and task dot length could be 5, 10, 1, anything, right? But whichever minimum, that many threads we will spawn. And helper is a mapper function. So mapper function is like, for this two size array, there would be two mapper functions. So like, two mapper functions, like for each index, right? So this is why we are creating a two threads. Currently our limit is 2, right? Over here we have given limit 2, so 2 threads would be created. Okay, now when the first thread gets created, as I showed you in the image over here in the Excel draw, that when the thread is created, our first task will start, and in the second thread the second task will start, right? So how is it happening over here is, so how it is happening over here is, this helper function is created. Currently the first helper will have this index of 0. Okay, the second helper will have the index of 1, है ना. Now due to the concept of closure, we will be having this index available to this helper function every time. So when index of 1, let's say the task 2 gets completed, so it will increment it to the third task and will call it over here. So simultaneously it will be happening for each and every task, one after the other, one after the other, one after the other, right? So this is how this will happen. Once our helper function and this task limit is hit, so we will spin out a threads array. Threads array is again nothing, an array of output promises which will be which will have this asynchronously available output array, like output for that particular index. And when we will give this to Promise.all, what Promise.all will do, it will execute both the threads. It will execute both the threads, like we have given there, no, 2 threads. So let's say 2 threads, 3 threads, all the threads in concurrent manner, and each thread will take the values from here. So our function will keep going, and once everything is all the threads are executed at once, we will get the output. In output we'll be having our every data, because it is again it is a closure over here. So this output will contain all the data. It is sort of a state we are storing over here, right? These two are sort of a state variable, index and output, and this will be constant across this whole function run. So this is how it will work. So let's see it running. Okay, so you can see, right, A, B, C, D. So we gave it, like, first A came in, it had this data, then B came in, it has its data, B executed, then C started. At the same time A and C were there, both ended, D started. So this is how, and our order is also preserved. It is not like we get A first or B first or C first. So first, it is not like that. The order will always be preserved. So this is how we perform this pooling thing, and yeah, that's all. Thank you.